Good morning. We're off to a bit of a late start. We're off to a late start with people being here too. We've got 2 of the 5 that are signed up in class right now. So I decided I would start doing my recording. This will be pushed out onto the website a little bit later. As far as synchronous streaming goes, I understand this room is capable of that, but right now I'm not planning on doing that, and people have to push on me. So those of you that watch this or maybe contact me later and I point you at the video, you got to communicate with me so I know what it is you'd like to be able to do. I would like to just teach in the classroom. That's been my desire since I guess since it looked like things were getting better, and then of course we went back to masking again. And do the asynchronous part so I can just focus on who's in the classroom. So, and I may be doing some tweaking. I've got, right now, this is a much higher resolution screen than I'm used to recording on, and I'm capturing all the pixels, so my computer may blow up at some point when it says, oh, you've captured too much data, and I'm gonna probably spend hours compressing it, but it'll just be the way it is until I decide to change my resolution for my recording a little bit later. So what I'm going to do, I guess I'm giving you a tour of the website right now, but then we'll get into the lecture notes and where they are located. They're located on the website. So the syllabus that you have in front of you, or if you end up watching the video, and I'm going to try to broadcast a message out so those of you that are here will get the same broadcast. I can do that from my UCCS login, which is the opposite of yours. Mine has all the class rosters, and then I can communicate with you people. But the website here is, they changed the URL for it last spring. It's just ece.uccs.edu, which you can see up above there. And you can also find it from my department's homepage, I believe. And then it's tilde M. Wickert, and then the various courses. So if you were to go up to the level above this, this is my personal website here on the campus. And then I've got a lot of links in here for various courses. And I've got, just for fall 2021, the other courses that I'm involved with teaching. So we're down here in Comm Systems 2. But just, if you were curious about Comm Systems 1, because maybe you took it somewhere else, that's 5625, so that's available. There's all the lecture videos are available, all the lecture notes and so on are there. So dropping back to where we were. I'm just going to give you a tour of how I run the website. I don't use the course management system that the campus has, which is, what is it right now? Canvas. I do not use Canvas. I'm old. I don't want to use Canvas. I've always written my own website, so there may be a Canvas placeholder for this class, but I'm not planning on using it. This website is open. You can get it from anywhere around the world. I have customers all around the world, actually, and I have people that, not in this class, but I have people that sometimes are distance ed students that will watch it asynchronously. I mean, I've had a PhD student in California. I got another one in Omaha. So I just like the open style. Canvas is a lock system, and one thing nice about having an open website is people find out about me, and I actually market. People find out about me because the Canvas system is closed, and I don't know. I've been wary of it, but any technology goes down. So there'll be times sometimes when this web server will not be available just because something breaks. But Canvas, I know, has issues like that too. So always in this left-hand pane is where I have the news, and I was last editing on this morning. And you can always see this from the upper bar here. But I last edited this column yesterday evening when I was working on my notes. So I put new news up here, new postings and other things. So you can just go here and find out what I'm up to in terms of what new things I may have posted. This is a hot link to office hours, and right now it says spring 2020 because I just haven't updated it. I'm going to update it. It will actually be in motion for quite a bit of time. But Tuesdays I'm going to be working as a consultant at the company I've been at while I've been on my sabbatical. I'm going to be over at their office or working from home. And I'm just putting this up as a placeholder. I'm probably not going to have as many office hours. You can see from the syllabus I'm going to have office hours immediately after this class, but I'm figuring rather than always meeting people in my office, we can do a Teams meeting or something like that, like some of you are used to already. Because my office is very tiny, I'm not even sure it's, quote, a safe place because the ventilation is not very good in my office. So both of us probably would feel not the greatest, not impossible, but so I'm hopeful that people will like the video conferencing. I mean, I know in spring 2020, when I last taught before my sabbatical, the video conferencing was working really, really good. And I actually didn't use Teams at the time. I didn't use Zoom at the time. I used something that was totally free, and I set up a messaging system called Slack. Have any of you ever heard of Slack? And I still have my Slack workspace area, and I'm contemplating adding everybody to that because I can create a separate, whatchamacallit, I gotta remember what the names are called. Pardon me? Yeah, channel. I can create a separate channel for each of my classes, and then we can talk one-to-one communications or whatever. So if you want to give me feedback, what you like, I mean, I've had to use Teams the past year working for the company I've been at. Slack I find to be a little more laid back. It's free, and if I was to bring up my Slack that I've got on here, and of course you can put it on your phone. So right now it's pointing at my channel, but you can have multiple channels on here. So right now I have a channel called DSP.com Courses that I created. I deleted a lot of the names, but I can add everybody to this. I might just add everybody to it, and then you'll get an invitation, and we can decide later if we want to try to use it. But I still am in contact with some people, but nobody's connected to me right now. But typically I was using Daily, which is a free video conference, and that was how it started. You know, what I mean started, when COVID started in March of 2020. And nobody said anything about what we were supposed to use. Nobody really knew what we were going to use because, I don't know about you, but we just weren't doing that. It just wasn't something we were doing. So I had used Slack attending the Scientific Python conferences quite a few years in a row. And I had a student at the time who said, why don't we set up Slack? So I said, okay, I'll do it. So, and it was also valuable because I could keep Slack running when I was teaching on my tablet, and then sometimes I would communicate and gave exams through Slack, you know, pushed things up, took things off. I just have to get the pulse of you guys. Teams I like, but...
I'm good with that.
Okay. I find, like I said, Slack is more laid back. Microsoft Teams just seems to be somewhat invasive. It's just so everything. But would you agree? I mean, I've got it on every device because it's the official university messaging system. But we'll talk about it. I'm also going to be meeting with my DSP class on Wednesday, and I'll kind of get a sense of what maybe they would like to do too. But at any rate, getting back to this office hours thing, this will be looking different. It'll have all these courses on here. This happens to say spring, but it'll have the courses that I'm teaching, which are on Monday, and then I have 2 classes on Wednesdays. I have the DSP lecture early like this at 8 o'clock, and then I have a DSP, real-time DSP lab right after that. So get off of this. So the syllabus we'll be going over is posted right here. Lecture notes and things are in here. The intro lecture is actually chapter 1. We'll be going through that. First off, we'll maybe get into chapter 3. Chapter 2 that you can see on there is something that I don't use anymore. It was an attempt at trying to bring more software-defined radio and development into this modulation theory class, but then I decided it was just too much, but I still leave the notes up there. It's a review of DSP and some things related to software-defined radio. So we'll be going through 3, 4, all the way, 5, 6, 7, all the way to the end. I have a link in here still to old MATLAB code. I do not use MATLAB anymore. I use Python, and now I'm exploring Julia, and we'll be talking about that throughout the lecture today. This tab, when it expands, has all of the old lecture videos on it. So the way I work this is the asynchronous video stuff that I'm talking about. What I do is the old videos are up there. You can see sometimes there is a failure, like lecture 2 didn't get captured, or I couldn't process it, so I had to put leave file of 16 up there. But what I'll be doing is I'll just be replacing each one as it gets processed. So there'll be an FA21 that will show up in there, and then I'll gradually just cover them. Does that make sense? One of the things I can't do, I mean, the perfection is, does a lecture 1 year start and stop at the same place the next time? What do you think? No.
Sure.
You just can't do that, right? My life's not that regimented. I'm not a robot. But it's close enough, I think. It generally works well. This tab here has got the first problem set, and then there'll be a link to the hints page. So I have a hints page to help provide some hints on approaches and things like that. And that will get set up when we take our break, this mid-morning break. I'll establish what is going to be the password for documents that I want to be locked on the website. You might say, why would I lock things? Well, solutions, when I'm using a textbook that's well established, I don't want to be part of putting things up there that can be found by somebody else somewhere, and I just want to keep things private because I want to preserve the integrity of the solutions and that sort of thing. So I will be locking the solutions. Right now, though, the course notes, I'm going to start to not lock them anymore. I'm very close to retiring. This very likely is going to be my last year of teaching. And people always ask me for my notes from around the world, and I just have kept them locked, sometimes for copyright reasons, but I'm not going to worry about it as much anymore. But chapter 4, 5, 6, and 7 are still, you can see the dates on there. I haven't done anything with them, so I will re-push those without a password. But if I get inspired or get worried that maybe somebody's going to be upset about it, copyright something, I may lock them again. I don't know. The reason why I would lock them is if there's something in the notes that I don't have full permissions for, I could get myself in trouble, right? We're not going to be in trouble as student and professor because, we have purchased a copy of the book somehow or another, right? So we're not at risk. It's just whether or not somebody would want to come after me for that. There's all kinds of issues with that, right? I mean, I don't run into it as much as other people do, but there's a lot of things that don't get posted legally on the web, and then people can get brought to justice under that. So don't go trying to grab the other stuff. It will get up there as needed. I do have some Jupyter notebooks that I've used in the past. Some of these dates are not, the first one there says 2014. That one probably could be revisited, but these will get updated too. Right now I have some new ones that I'm working on, and if I decide to push down more on Julia, which like I said, I'll be explaining, I'll do that too. I don't know, has anybody, of the two of you, have either of you heard of the language Julia for scientific computing?
I've heard of it, but never used it.
Okay, how about Python?
I use it all the time at work.
Okay,
Yeah, I use Python.
okay, great.
From here in Julia.
Oh, pardon me? What did you say about
Python and not
Okay, have you ever played with Julia?
No.
Okay. I've just been exploring it since a year ago this summer when I attended their virtual conference for the Julia community. And it's got some cool things, and it has a notebook of its own, and it's called Pluto. They have to be different from Jupyter, but actually Jupyter, if you know what it stands for, it's Julia, Python, and a couple of other languages rolled up into one, because Jupyter is actually an open notebook that you can run. I use Octave in it at times when I'm working, because if somebody wants me to use MATLAB, I'll just use Octave, and then I'll use a Jupyter notebook with Octave code in it. So it's pretty nice. I do like Python a lot, and I'll maybe explain that. You can see Signals and Systems for Dummies is a book I wrote in 2013. Why did I write the book? It's because they came to me and wanted me to write it, so I got paid to write the book, and it hasn't made a bit of money for me since then. I mean, I got paid to write it, but it's not a big seller. But it got me into using Python, and then it got me into developing this package, which we'll be using a lot in this class, and I'll be talking more about that a little bit later. And Python projects are down here. When they get assigned, these are the old ones. I might just make minor changes and then get them reposted. So don't go off and be super pumped up that you want to work the project and then say to me later that I did all this work and now you changed it. Well, I have the right to change it, right? But if you want to take a look at it, that's fine. They'll probably change. And then eventually this gets filled in with exams and old exams with solutions if it rolls out that way. How's it going to roll out? I don't know. I'm nervous that we're going to be back to remote learning sometime, but I don't know. Any of you want to speculate what's going to happen? Yeah. Okay, so I'm done with that. We're going to get back to the syllabus here briefly, but before we actually do that, I'm just going to start off with the lecture notes that I have. These are all prepared using LaTeX, so they were done in the typesetting system LaTeX. But I will be explaining to you that, and if you're wondering what this document is right here, this is intro lecture is what we're looking at right now. Last updated at 10 last night. So I thought I'll spend a little bit of time on this picture. Let's see. I actually have my pen, so I can write on these things if I want to. Good thing I got here a little bit early. This is a Microsoft, well, it's a Dell tablet, but this has a little tiny battery in it, and in the last year, it went dead. But I had a spare, so I put a new battery in it, and I believe it's working again. Yep. So this is a generic digital communication system, and it has the core elements in there. But one thing that's not really well defined at all is the channel. The channel is a whole huge subject unto itself, but we always have a source of information. It could be a digital source, it could be an analog source, and then we have optionally an encoder to provide some forward error correction coding. And we'll talk about coding theory at some point in the class. There's some chapters in the book on that. And then we have a modulator, and
Sorry.
yeah, go
Is it
ahead.
coding things like 811s and stuff that are used for SerDes, or is that different?
This is information theory coding, as in forward error correction is the typical thing, or compression.
Okay.
It's not for security at this point. So when you say SerDes, are you talking about certificates or?
No, like serializer, deserializer.
Oh, there is serializer and deserializer, but that would generally sit, if we were actually wanting to talk about that, that would be, wait a minute, wrong thing. Oops. That would be over in here. I can get my fingers working on the touchscreen. There'd be a little serializer in there. If we're talking about a high-level modulation where we bring in a serial stream and then we convert it to one form or another, and that's common. So yeah, the serial to parallel converter of some sort is what I'd refer to it as, but that's another type of encoder, so I guess, yeah, it's ambiguous. So your question is fair. I don't have a problem with confusion on that. So then the modulator, and the modulator, most systems we talk about are carrier-based. So we're going to have a carrier frequency, and then we're going to place this modulated, this modulation type or waveform type onto a carrier. But it doesn't have to be that way. It could be optical, and it could be at baseband then. It could be twisted pair, like we use for the backbone. We're going to review some of that stuff too in this opening, but modulator is all kinds of things. It doesn't have to be carrier-based though, but most of the time it is, but not always. Then we go through a channel, and the channel can be ideal, and it might just contain additive white Gaussian noise because our signal is not overpowering. We're trying to conserve energy, and then we have the front-end noise at the receive side. But in reality, most applications, the channel is very exciting. I use the word exciting because my view of the channel somewhat is like it's gonna mess your signal up to the extent that at the demodulator there, it's very challenging to grab onto the signal. And an analogy that I like is trying to ride a bucking bronco in a rodeo. And do you know what a rodeo is in the U.S.?
Yeah.
Okay. So the idea is you're trying to ride the horse or the cow or whatever, and it's trying to throw you off. So from a demodulation standpoint, you've got to lock up your carrier phase, you've got to lock up your bit synchronizer or simple synchronizer, maybe your spreading code, maybe some other sync patterns that are associated with cellular in particular, but could be various modulation schemes. And it's challenging, really challenging, if there's a lot of disruptions in the channel. But then the other things that the channel has in it, it's not free of other users. So you have adjacent channel things that can happen. We'll play around with some of that. It can be, so we can have adjacent channel interference, we can have co-channel interference. So co and adjacent, which is, just to make sure you're clear, which do you think is worse, adjacent or co-channel, just terminology-wise?
Probably co-channel. I see that.
Yeah, it's right on top of you. or it's overlapping with you, so. But code division multiple access, which we'll talk about eventually, allows for that because it uses a spreading code to make the waveforms approximately orthogonal. So that was a cool innovation. And we used to have that in 3G cellular when we had CDMA, as it was referred to. And so that's how channels get used, though. In general, we have a whole bunch of multiple access schemes, and so we have things we'll eventually talk about there. We have things like time division multiple access, frequency division multiple access, code division multiple access. You can have space division multiple access, and what else is there? Those are the main ones that I'm familiar with, but anything that allows users to be separated from one another. I've studied cognitive radio quite a bit, and I've had students work in cognitive radio for their research, and cognitive radio is sort of a different animal. It just says we're going to respect one another, and if the primary user is not using it, then a secondary user is free to use it. They still have to share amongst secondary users, but they have to immediately not use the channel as soon as the primary wants it back again. It's a concept that has not really done as much as I thought it would, but when I first learned about it many years ago. But we still use, since I'm on channels, I'll just diverge a little bit more. When you're sitting in your apartment or your house with your neighbors around, and you look at your Wi-Fi network, for example, how many other Wi-Fi networks do you see? You see a lot, right? In an apartment, you can just see scads of them. Even in my neighborhood, though, I see at least 6, maybe 7 or 8. So our wireless routers actually do perform some form of cognitive radio, this is my view, because they will help locate your Wi-Fi channel or band and try to pick a clearer spot compared to the other users in your neighborhood. Is that believable? I mean,
I've seen that like Wi-Fi has like 10 subbands and it tries to pick one, or
yeah.
sometimes a router lets you pick one, right?
Yeah, exactly. And then you have another bad thing is that microwave ovens came first before Wi-Fi existed. And that's in the 2.4 gigahertz band. But in my house, my microwave oven is a new one, but it radiates quite a bit, right in the band where my router sits. And I feel, my family says don't work on it, but I brought home a FieldFox spectrum analyzer, and I played around with it at home, but I feel like what has happened is my neighbors have forced me into that band, Wi-Fi band, and it's kind of like, they're forcing me there, but that's actually right where my microwave oven hits me. It's like I should pick another band, but I'm closer or overlapping with somebody else in my neighborhood. Interesting, right? Because I've heard of it situations where
Trade microwaves with them.
Pardon me?
Trade microwaves with them.
Yeah,
So
or...
you can detune it.
Well, I've talked to people that just know that their neighbor's on the same band, and they feel like they don't get much throughput, and they could talk to each other and say, hey, we could do something about this. We could maybe change our band. I don't know. In the very beginning, you had to do it manually. Now it's done automatically when you buy a router, right? But this is comm systems, so we're supposed to be smart, or at least we can apply our knowledge to even things that we take for granted if we want to. At any rate, moving down the line, the demodulator is actually more complicated than the modulator. We'll spend a lot of time talking about demodulation. Then we have detectors, which could be simple thresholding devices typically, but I've shown in here there could be the synchronization subsystem actually if I was looking at this, I might just say these are all connected together because there's various subsystems. In a class that I taught last spring of 2020 was phase lock loops and synchronization. So that got into the various levels of synchronization and tracking loops and how you decide how you're going to actually, what your architecture is going to look like to implement that radio. And then the decoder is the flip side of what we have here. So we'll look at block coding, we'll look at Viterbi or convolutional coding. I don't spend a lot of time on that because there's a lot of other things to do, but I do have that in my Python package, which we'll be talking about. So I have the encoder and the decoder, soft decision decoding, and things of that sort. Then if we're going back to analog, digital analog converter, if it's just a digital link, it just comes back out as a serial stream. So there is a parallel to serial then at that end that converts the symbols back to serial bits. So now onto the formal part of what I have in the notes. I'd just like to give a perspective. In the curriculum, we're going to go through the course topics, spend more time on the syllabus, some policy things, talk about software tools, talk about things that maybe could happen in the lab or some other options for that. I feel really good about, even if we have to go to remote, I can give you test vectors. In reality, and I have software-defined radio hardware that I can play around with all that stuff. I'd love for you to be able to do that in the lab yourself, but the cool thing is I can just give you test vectors. You can generate your own, but I can give you vectors that were captured off of a real receiver that have all the bad things in them. I mean, the clocks are asynchronous and carrier's not known exactly, or maybe it's drifting. We don't start off there, though. We start off with everything being nice and perfect, and then adding realism, though, I think is really nice because I think it's good to learn about that at a young age, because when you get the real thing, it's like, I can't do anything with this. My simulation works perfectly, but you've given me some captures, and now I'm having problems with it. And anybody been there, or can you relate to that a little bit?
Yeah. When I started working my job, I was like, this is nothing like school and you guys are all black magicians.
Well, the place that I've been working at on my sabbatical is a satellite company that makes small satellite systems for reconnaissance types of things, government types of things. But the cool thing about working for the company is it's not a company that builds ground station equipment. It builds a little tiny stack of modules. It's a payload that goes in a satellite. They don't do the aerospace part of it, but they build the payloads. And so right outside my office, there's the lab that has all this nice test equipment, and software-defined radios are floating around everywhere, and captures. Some of the things that we did in the lab are the types of things I would think of. I was working on, and I'll be explaining some of my experiences throughout this entire semester, but they would get me test vectors. So sometimes we didn't have the captures because those are going to occur in a different environment. Those are classified. I don't know exactly the scenario. But in order to get real waveform captures, my boss used MATLAB to generate test vectors and then put them into an arbitrary waveform generator. An arbitrary waveform generator generates this long record length of data, and then the lab hardware engineer turns on the arbitrary waveform generator, puts out the signal at the carrier frequency or some IF frequency, and then it comes in through the radio front end. and then the long record was captured, and then they do some post-processing. Maybe they sub-band tune it down to a narrow bandwidth, things like that. I mean, things that are, makes you feel like you're really doing the real deal. But I'll be talking a lot about that. The last thing about my experiences, last thing in this chapter is just a review. So this is the slide that kind of puts things in perspective. This is kind of a marketing slide for what has been my area and is also Dr. Semiari's area. As soon as I do retire, it's his baby. I mean, he's got this. He'll be running it until if they're able to hire, the department can hire somebody else. I don't know. But just to be clear, we're right in here, Comm Systems 2, which generally follows from Comm Systems 1. I've always used this Zemer and Tranter book. A couple of reasons I've used it. Number one, Roger Zemer was my dissertation advisor. He just passed away this past January. Sad, but he had Parkinson's, and which was not making his life any easier, but he also got caught up in COVID. He had to be in the hospital, not for other reasons, and they think that led to his final, going down. Sad, right? If you have to be in the hospital for another reason, but because COVID was in the hospital, family couldn't be there. I mean, it's a pretty sad story. I know his wife really well. I know his children. We go to the same church, so I know him really well. I knew him, but I know his family really well. But this book, when it first came out, I was a student, and I learned out of the very first edition. And then when Roger Zemer was the department chair here, he always taught this class. I never got to teach it, and then when I started teaching it, I wanted to just use his book. So I have the paper version, but I also have the PDF version, and that might be cheaper for you if you can get that. It's not that terribly expensive, I don't think, right? You might even be able to get a used copy of it, I don't know. I like it, and people could argue that there's so many great books out there, and that's the whole problem. There are so many great books, but what is the best book? And one of the things that I have in my office are some really super thick, dense books, but there's just too much stuff in there. I think for teaching a class, it's better to have a more concise, book that doesn't go through that much terrible detail, because it's just hard to keep that going. You can go grab that stuff when you need it, is what I think. So there's where the course sits in the lineup of courses. We used to have a SATCOM class. That faculty member left. We used to have a wireless and mobile communications class. I think Dr. Semiari wants to get that going again. I taught it, and Dr. Zemer originally created it. And we used to have information theory and coding. That's the same faculty member that was teaching satellite communications. He left. Dr. Semiari is his replacement. What else did we used to have? We used to have wireless networking. I thought about revitalizing that. That was 2 faculty members ago. I'm an older faculty member, but every time when Dr. Zemer retired, we tried to bring in a replacement, for him, since he retired over 10 years ago. And every time we brought somebody in, they didn't last more than a couple of years, which you might look at me and say, it's all my problem. There must be something that people don't like about me. They won't stay around. But I know that's not true. Fortunately, you can see maybe my expression on my face that I'm kind of smiling about it. It's just some people have to keep changing jobs because they're not happy. But these things are all relevant, and what you can always do, like spread spectrum, I've taught that on again, off again, And this class down here originally was frequency synthesizers, but now it's PLL and synchronization is what I found to be more relevant. Radar systems used to be taught by Dr. Zemer. We actually had image processing in here at one time. And then we had a whole semester of random processes that I used to teach. But a lot of these things, because of downsizing, I took all of those things and moved them into a one-semester class called Statistical Signal Processing, which I don't know, it normally would be taught alternate springs, and it wouldn't be taught this spring. It would have been taught last spring when I was on sabbatical, but it's possible that if people wanted to have that class taught this spring, it could be my very last time to do it. I could not do something else very readily. So I'm just pushing that out there right now. Notice it says odd. That would mean it would have been 21 or 23 and so on. But things that are more advanced are on demand. And if you're Dr. Semiari probably will be teaching something for you, Fatima, right?
No, I didn't get any course with like the seminary, but I think he has a satellite communication is good.
Okay, I didn't quite hear all of that, but because I'm having a hard time hearing with your mask on. But he might do an independent study with you, though, right?
Yeah, I should get.
That's what I do for my students over the years. I've done that. On any of these topics, I've done the independent study. I mean, the last request I had was, while I was on sabbatical, somebody said, will you do spread spectrum? I just decided I wasn't going to kill myself during my sabbatical. I had two master students finish, and I was working with PhD students somewhat. But that's just an example of how that can work. Okay, I've already talked about some of these things, but I'm noticing here, I've got written in here, have to limit the depth on any one topic. And this is where my personal interests and my personal experiences lie. If Dr. Semiari was teaching it, he might drill down on that. I'm going to drill down on certain other things that I've done over the years. He's really big into 5G. I haven't really been doing much of anything in 5G. I used to do things in cellular, and then I got more into aerospace electronics, government electronic type stuff, and consulting work in that type of stuff. So I switched back to another direction. It just depends on what's going on. I've done a lot of different things for different people. Like, right now I have a side project going on in an open source hearing aid that will have hopefully some deep neural network learning capabilities, maybe with some edge processing. And the idea is to have enhancements and noise reduction capabilities. So I've been working with a company here in town. We're trying to get funding for it. So it's still signal processing. It's just not communications. It could have some wireless interfaces on it when it finally gets implemented. But it's a product. It's not just an idea. It's something that's got to be hardware. And there's actually a meeting with a company called Maxim today. We've been looking at some devices and talking with them. And they're, I think, willing to actually change some of their IC design to fit the needs, because they're wanting to, a hearing aid is going to sell a lot of devices. So And the guy that I'm working with used to work for a hearing aid company, so he has experience with the whole everything, not just the software that runs on the hearing aid, but actually making the shell and all the other pieces that go into the hearing aid stuff. And one of my PhD students has been working in binaural type signal processing. He's doing deep learning for trying to fit models and measurements that were taken of human subjects to a, what he calls, or we call, a personalized head-related transfer function. Have either of you ever heard of the HRTF or HRIR, head-related impulse response? So each ear has got an impulse response spatially, so it involves three-dimensional angle of arrival, but it has an impulse response, or like I said, frequency response if you Fourier transform it. And we're all unique. It all depends on lots of anthropometrics, which is the stuff, you know, from your shoulders on up pretty much. What is the size of your earlobe? I mean, everything impacts how the sound gets shaped. And I became interested in this, and I actually have a Python paper, SciPy conference paper, and the software that goes with it for 3D audio. It's very interesting now, and when people become hearing impaired, then they lose their ability to hear properly, and our hearing is, since we were babies, our brain learned how to sense when we're outside. Is the sound behind me? Is it back over there? Is it back over there? We just take it for granted, right? You walk outside, you hear, and it keeps you from getting killed probably when you're crossing the street. I mean, it's that significant. It's very, very interesting. Of course, our brains can relearn, but we each have a unique HRTF. And in the business of 3D audio, there's also special effects things, or the potentiality. Once you have an HRTF, which would be characterized over many spatial arrival angles, that you could provide very realistic immersion into medias and things. You know, you have the visual stuff. This is the audio stuff that goes along with it. I think Professor Semiari is interested in that kind of stuff too. Maybe not the audio side, but just the immersive things that you might have. So I've done some stuff in that too.
Oh, so like to play through headphones,
Yeah,
through your HRTF to make it sound like it's there.
exactly. I built a simulator in Python that I can fly things around your head and give you that sense. Or I had another student who did it with a facial recognition system, so that you were wearing the headphones and the camera system was tracking your head, so when you moved your head in that direction, the sound would move accordingly. And his example was a cricket chirping in the background, so when you turned your head, it would be like, does that make sense?
Yeah.
It's pretty,
It's looking forward for virtual reality.
yeah, exactly, virtual reality. My brain was not thinking of the right term, but yeah, virtual reality. So, but the HRTF and the deep learning is just so you can personalize it. If you don't want to personalize it that way, then we were looking at using photogrammetry, where you take a 3D picture of your head, and now that's become very sophisticated and very doable. And then I have a package called Console, which I have the audio module for Console to do. Console does multi-physics, so it's solving the acoustical wave equations. You know, in comms we use electromagnetic waves, but in acoustics you use sound pressure waves. So same idea, get a 3D head model, then you can calculate by solving in 3D the acoustical wave equations to get those responses. And So that's what this student has also been doing too, or at least looking at. People are playing around with this stuff around the world, but hey, we all know that, right? There's so many different things to do. But I've gotten excited about that because that is related somewhat to the hearing aid project. Because actually, since I'm already really off track on that, I would like to have the device where the automated device would be great, but even a manually tuned device where I would be looking at you would be sitting there talking to somebody else, your speech is coming at me, and it's aggravating my ability to hear, so I can just tune you out and tune you in automatically. It's called the cocktail party problem. You may have heard of that before, but even to have a directionalizing means like beamforming, but all very interesting stuff. How well does it all work, and how many watts of power does it take to do that? But edge computing is a factor in that as well. So things we have to do to get started. Just because I want to provide a nice on-ramp, we're going to review probability and random variables. And then something that I'm assuming you've had no experience with is random processes. That's necessary background for understanding signals with noise and just randomness associated with things. And digital comm would not be nearly as exciting if we couldn't have random processes for our modeling. Waveform aspects is key to digital comm as it is with analog comm, but digital comm, it's very exciting because that's where people have been so innovative. The idea is we know we want to send bits, ones and zeros. How are we going to transform that into a waveform that's makes very good use of the channel? That's where all the novelty comes in, is how do we design waveforms? And there's various requirements on waveforms. And that's fun. It's very fun, actually. I love modulation theory because the waveforms make things very interesting. You'll always be involved with that if this is going to be your area of work for your entire career. Waveforms come and go. You rarely are the person that designs the waveforms. And why would that be? It's because standards bodies are part of the waveform design, right? But you may end up being a member as an employee at a company of a standards body, so you might influence that. I've been involved with military government systems where a small group of people, maybe a university professor, in fact, in one scheme I was working on building a receiver for rather recently, influenced the design of this particular scheme for a telemetry receiver. And it's not really a MIMO type system. I guess it's an idea that came around just pre-MIMO, and it's called, let's see, what's that scheme called? It involved only 2 channels. I'm trying to remember what it was. It was a perfect design of a waveform, though, where we're trying to be very bandwidth efficient and trying to take into account characteristics. As an airplane flies around over the ground station and they're testing the aircraft out at a test range here in the U.S., how could you make sure that you don't have shadow? If you have a single antenna on the aircraft, as it's banking, it's going to shadow it. It's going to get more multipath, and the telemetry data is not going to get pulled down as effectively. So put 2 antennas on, maybe one on the top, one on the bottom of the fuselage, and then you can combine that. So spatial combining is taking place, and the receiver was extremely complicated, like very, very complicated. I worked on it for a couple of years as a consultant on learning how to make this work, and I came up with a much simplified approach because it was taking too many FPGAs to do it, even for a ground station. So I don't know why they came up with this sophisticated of a system, but they wanted to be bandwidth efficient and get power efficiency as well. I'll just mention this briefly. Software-defined radios have made playing with digital comms a lot more doable, and I've got a collection of SDRs I like to play with. I'm going to show you some pictures. I decided to not bring any of my radios in here today. But it's actually possible to do some real-time, and actually this right here is part of my Python package, Scikit DSP-Com, and then now a sub-package. It used to be built in, but now you have to install a sub-package called PyAudio Helper, and there's actually SDR Helper too. That's another sub-package. But it's possible to do low-frequency real-time audio right on your PC using Python. It sounds kind of crazy. It's just so you could simulate something where you would have the asynchronous behaviors. That's one of the things that, because I've been so interested in synchronization. But I have the capabilities in the Scikit DSP-Com package to do that. I mean, I have modules in there, functions in there, classes, but I can't remember. I guess it's just a function in this case where you can perturb the, it's called the time delay function. It sounds pretty simple, but it's not just time delay by a fixed number of samples or fixed number of seconds. It's time delay as a function of time.
So do you use a sync kernel or something?
Do I use what?
Do you use a sync kernel or something?
No, I'm using a Lagrange interpolator.
Oh, okay.
It's a continuously variable time delay with a third order Lagrange interpolator, and then so you can actually take a waveform and you can warp it and de-warp it. But if you take it to the extreme, I mean. In the real-time DSP lab this semester, they actually play with that idea, but a much simpler interpolator for a special effect in audio called flanging, which is an age-old thing from the analog days of recording. But for purposes here, it's very interesting because we can model things that would happen with Doppler. You can get effectively you're modeling Doppler. So, and the impact of Doppler on the carrier frequency can be done simply, but if you want to do it down at the symbol and baud rate, then this takes all of that into account. So that can be done in simulation too. And we can also put up widgets and things in the Jupyter lab for controlling things. That was in a paper in the 2018 SciPy conference. So now we're going to switch over to the syllabus, and to do that, I'm going to bring that up separately so I can get access to the hot links that are in here. So we've already talked about quite a bit of this stuff, but this is the document that I handed you already. So this has just got the relevant stuff on it. I know I'm probably sounding ridiculous about certain things, but this is the contract, effectively, for the class. I mean, that's something that we're supposed to have, so you know what to set on. Now, we can change certain things, like how many exams, what are the weighting, and all that stuff, but I can only make changes after today with everybody agreeing to it. Does that sound really formal? For where you come from, maybe you would never even think it could be that way, but here in the United States, it's like we have to have a contract. I mean, I call it that because that's what it is. And I see I didn't change this syllabus. No, it is right, never mind. The website is ECE again. It was EAS, and then they changed it back to ECE. So right now I'm proposing office hours from right after this class. We could either stay in here and discuss, But probably another class will be coming in, so we'd have to go somewhere in the hall or something like that, but we can work that out. And then I'm also, rather than adding in a second day, I'm just saying by appointment. And daily is how I've got my Slack set up, very conveniently, but Teams or Zoom. So maybe when you leave here, and this is you two or any of the others, you'll just say, can I make an appointment with you? You might email me, I'd like to meet on Teams, or if we use Slack, we'll meet on Slack, and then we'll launch a session on Slack, and we can go over problems or something like that there. My office is available, but I'm just not sure right now how much time I'm going to be spending in there. But we'll work something out, and I think all of us learned during COVID, you don't have to be in an office and looking face to face at anybody. I liked that at one time. I've gotten used to the idea, though, in my work all this past year. I'm working on code. I want to talk to the embedded systems guy. I want to show him something. I start up a session, share a screen, look at code, help me debug something, or show something to my boss, like here's some new results, push that into the Teams chat, or all that stuff. But what I found was really, really good fundamentally that I could do in Teams, let's say, was do a phone call, not a video, just simply a voice call. Worked really, really well. Sometimes you just need to talk, and I'm a big fan of that, because typing a message, waiting for a response, typing it out, I'm not a very fast typer. I was like, no. I click the little phone icon and we're talking. How do you guys feel about that? If that's appropriate, I mean, just jumping a few messages, okay, but if you really want to talk, we'll get a lot more information conveyed.
That's right.
It's information theory though, right? We are sending more information when we speak. There's a lot of more information than when we just send a text message. I'm smiling about it because that's what.
We need to save the bandwidth.
What's that?
We need to save the bandwidth.
Yeah, exactly. It's like conservation. I mean, we're the few people in this campus that understand all of this stuff, and everybody else, they take it for granted, right? They think everything's going to be there all the time, and they don't realize the extremeness that the engineers have to go through to make all this happen. It's amazing when it works, though. So the book I've already talked about, the optional text, which I've just left in my syllabus. I still like his book. It's good for DSP implementation, and it has a good digital phase lock loop and synchronization material in it. In terms of Python, if you guys are both set up, I'm not going to tell you how to do it. For the others that will watch this video, I will give you some ideas on the second page of this document. I prefer using Anaconda, and I actually like using Miniconda is what I set up, and then I set up virtual environments. You don't have to go with virtual environments. You just will probably be led there at some point in your career where you want a virtual environment of any language pretty much, but that's the way I do it. The full Anaconda is just a little bit too heavy for me these days, but it works. I mean, go with it if that's easier. I'm going to show you a little bit about how Miniconda would work here on the second page. If you're interested in Julia, I'm just going to see if this hot link works. This is supposedly a new feature of this editor. It might not work though. Oops, that's right. That's just that only. Now I get it all confused. Guess what? I'm just going to go this way because I know this will work for sure. The tool I'm using and that I can draw on is this thing down here called, it's called Drawboard, and originally they didn't have any hot links that I put in would work. And now when I opened it up today, it said we now have URL linking, but Maybe not, I don't know. So, I'm used to my Macintosh with the mouse that goes the other way, so this one's not right for me. This takes you to the Julia language, and you can read about what it's all about. I'm going to show you a demo of it here eventually. And then the guy that created Pluto, which has only been out for a little over a year, this is his GitHub site where everything is stored and maintained, and then you can see some examples. And I'm going to show you some examples. The cool thing about Pluto is it's reactive. So you change a cell here, it changes down here. Everything is coupled together in the notebook. It's not independent, isolated computing, which at first maybe doesn't seem like what you want, but this link will kind of explain that to you, and you can have interactivity with sliders and things. So okay, so the homework assignments going to comprise 25% of your grade, and there'll be one Python project which will be included in that 25%. There might be more than one Python project, I'm not really sure. Sometimes I have mini projects in homeworks where I'll say, work these problems from the book, and then I'll say, go off and do some simulation or some modeling on the computer. I want you to just do that interactivity thing on the computer. I want you to use the computer actually for validating your hand calculations or just using it all the time. I don't know, I'm a believer in, I like the theoretical part, pencil and paper, but then I want to go check something and get confidence that I actually know what's going on or I've modeled it somehow or another. So just freely do that because I think it helps you learn better. Don't work just with your paper and say, I can't get it. Go do an experiment on the computer. I'm going to introduce, hopefully later today, SciPy stats. I mean, NumPy has really nice basic stats, but if you were to delve into the SciPy package itself, there's a module called stats. It is amazing what is inside of there. I haven't done everything that it does, but if you actually use that rather than the basic stats that are in NumPy, you just find it does everything, and it doesn't do just Gaussian, random variables or uniform. It does, the list of PDFs is huge. The types of distributions. Oops, got excited and knocked that off. For you guys watching the video, there's going to be a giant shocking sound there of it crashing. Okay, there'll be a final computer project, and actually what I've done, I'm pretty sure I'm going to have to check up on this. I can't draw on this, but 2 and 4, the final exam and the final computer project have sometimes just been rolled together. So there'll be some problems that are work out the answer with theoretical stuff, and then there's some simulation and computations that are rolled up inside of that. I actually am a bigger fan of that myself. There'll be 2-hour exams. One of them I'll have you take in the class. I just want to have that controlled environment, and then one will be a take-home exam. Any questions about that? These are the topics. They're right from the book. Chapter 1 is an introduction and overview, and then if I was to modify it, second topic is chapter 6 out of the book, chapter 3 in my note counting index, and then random processes, 7. And then the way the book is organized, I have to jump back a little bit into chapter 5, the way it got organized for principles of baseband, and then into data Principles of Data Transmission. It has to do with the way he wrote the book, and he was trying to experiment with different ways of teaching it between a 2-semester sequence, so he shuffled things around. I'm very old school because I've used the book since the beginning, and he had it one flow, and then he, pulled things out, like I said, to give some better options for a 2-semester sequence. And then the advanced chapter, which covers a lot of different topics, and then as much as we can from information theory and coding, which I won't typically get a whole lot of time on that, but enough that I will give you things to do with it in your final project or exam. You'll be working with the modeling and bounding, say in convolutional decoding using the Viterbi algorithm. You'll play with soft decision decoding, and then you will simulate it in Python. So, have any of you heard of Rust, the programming language Rust?
Isn't that the one where it's like impossible to get it to compile, but then it says it won't leak memory?
Yeah, that's one of
It's
its
like the
features.
compiler is like very rude.
Yeah. I had a master's student develop a Rust module that runs in Python, but it's compiled in Rust because of the speed up that we were hoping to get. So the Viterbi functions that are in scikit-dsbcom, the module for convolutional decoding, we have a Rust version. It's on the website. I have not really used it because I haven't taught this class since it was developed. All I know is that he developed it on Windows. It gave almost a factor of 10 under some circumstances. Then I helped compile the version on my Macintosh, and I couldn't get any speed up at all. It came at a time when I was too busy. It wasn't COVID that threw me off of it, but it was something I thought about doing to be making it run more efficiently, because I wrote all my code in native Python, which is not necessarily super fast.
Same like NumPy is like written all in C and.
Yeah, exactly. But so I'm vectorizing the best I can with NumPy, but there's still the Viterbi algorithm we'll learn about is a trellis decoding, and it's very laborsome. That's what I got involved within that modem I was working on. I'm going to hopefully think of the name, the scheme that it uses. This last little colored blurb was something the dean used to say we had to put on our syllabus. I don't know if he cares anymore, but there is a last day to drop, and this semester it's October 29th, so I take it seriously. You are a graduate student, so you take things seriously. I'm not really that worried, but it's just understand that you can't go to the end of the semester and say, oh, by the way, I decided I want to forget about this class because I'm getting an F. I don't know how you feel about it, but to me it's like, wait a minute, it doesn't work that way. You're responsible. You have to be responsible. Your grade record is a lifetime thing. It's not that we don't like you, but I was treated this way too. It's just the way it is. Your performance is what you have. You can take a class over, you can maybe drop it with extenuating circumstances, or you can repeat it, but it's just, that's the way it's worked. During COVID though, the university pretty much gave up on that and said you could drop almost up to the very end of the semester. Right now, they're starting off with this October 29 date that possibly would change if we change modes again. I don't know. Learning outcomes, that's just up here for our accreditation. Next really big thing on here is COVID-19 and face coverings. Our provost gave us this last Friday late, and it just says we have to wear face masks until told otherwise. Because I believe I'm 10 feet away from you, I could take mine off if I wanted to. I mean, but you can't do that. It's just the way it's set up right now. And I have the right to say if a person doesn't want to, they have to leave class. But, you're not demonstrating anything, and I don't know about the other three that aren't here. I just have to inform you of that. Okay, things that I am interested in now. Scientific Python, it sounds like you're all, both of you are up on it. The others of you in the class, please read up on it and follow some instructions. My package, Scikit DSP.com, I used to have everybody get Git installed on their computer and then go to the GitHub site and actually install it. But the student that helped me develop the package, I'm the coder, I'm the algorithms developer, he's sort of the computer engineer that got everything pushed up and maintains. He's the maintainer. Is everybody familiar with GitHub?
Yeah.
Yeah.
I think every engineer these days, GitHub is, or Git, period, is very important. And GitHub in particular for public, shared sites. So I have my GitHub site and I have projects up there, but when I work, the company always has a Git server and you always check stuff in, and I don't know, it becomes part of your way of thinking. But nowadays, the package is very stable. It's now version 2, so now I'm not having you clone it and then do the .e in pip, so that you could easily refresh it by doing git pull on it if I made changes. There is something broken in it right now that I'm not happy with. It's Pi Audio Helper, which is a sub-package now. And that's for my DSP class. I have to figure out what's going on there. It doesn't work in Python 3.9, and I don't know what he did, but I have the old version of the module which works, so I'm just going to be using that until we can figure it out. If you write code, as much code as I do, you've got so many things to work on in a code environment. You sit down there and do a diff on the 2 files, and I look at it and I say, okay, he made some changes to it. Don't know, he wanted to make changes to be more properly Pythonic and things like that. And something broke in it. I just cannot figure it out right now. Have either of you ever been there? You stare and stare and you just can't see it.
Well, it's easier if you do smaller commits because you can like bisect and figure out where it broke, but if it's monolithic, it's way too hard.
Yeah, I don't know if it's that, well, it was developed by me and yet another graduate student, but the thing about Python as a language that I really like is you can import, you can give an alias, so I'll just give you, I'll give my DSP class the module and they'll import it, and then they'll give it an alias. I mean, you can use the alias on the import so that you can use the local version and not worry about the one that's in the package, because it's, hopefully we'll resolve it, but the good thing is it's not wiping you out. It's not like it's totally gone. And hopefully he'll get on to helping me with it, but I haven't been able to figure it out. So other tools that I happen to like a lot, Jupyter, is the mainstay for me, so I can't draw on this again, but Jupyter, very nice. I like all of what it does, and now there's the debugger that is even really nice. I can't get it working on this tablet though. It works on my other computer, so I may show you that, but if you need to debug, but there's also things like VS Code. I'm a big fan of using VS Code because I do a lot of other types of editing in it and development. There's also PyCharm. Do you use PyCharm?
I use Vim.
Okay. And then you're running Linux?
Yeah, I use Linux and Vim all the time.
Okay, I'm not a VI user, but I do use Linux all the time, so. VS Code though I like, and I use it on Windows, Mac, and Linux, and it's very consistent, and there's plugins and things, and for Julia there's also plugins for Julia as well. One of the things that is worthy of looking at is installing Typora, which is a very nice markdown editor. So you can re-author things in Typora. If you export out your Jupyter Notebook as a Markdown file, and then you can do everything in Markdown these days. You can write math equations in Typora. So it just so happens I have it running right here. I just created a new virtual environment with Python 3.9 yesterday afternoon, and so I decided to document my command line stuff. This may go up there on the website, but what Typora lets you do is you can, there's the source code, which is just a text file, and Markdown is the same Markdown that you use in a Jupyter Notebook. So you've learned enough about Markdown if you've been using Jupyter Lab or Jupyter Notebook, but this is just a keystroke to switch modes. So you have all the different tags available, and then, well, if I right-click actually rather than pulling up to there, but if I just right-click in here, and I want to insert code fence, which is the code blocks there. If I want to put in a math block, you know, I can just immediately start typing. And then you can see down below there, it's putting in my mathematics for me, right? It's LaTeX code. If you don't know LaTeX code, you have to learn it. I highly recommend learning it, but this tool makes it pretty easy to start learning it. So I'm just sort of messing around, but and it will get upset with you until you get it right. Now, when you're done with that, you just click away. And so what you can do with this, where this comes in really handy, is that you might export your Jupyter Notebook as Markdown, and you might want to tweak it. You might want to put some more things into it. You might want to fix some errors in the text part. And then you can go ahead, and once you're in this tool, you can export, and you can export to a lot of different types, but the one I use most frequently is just as a PDF, and then you can set a header and footer and have page numbers. Why does this matter? Because I don't like the basic export from the Jupyter Notebook is kind of not always consistent on the platform. You can export as HTML or something, or you can print it, but if you would spend just a little bit more time and export it as Markdown and then take it over to here and maybe clean it up a little bit and then print it out as a PDF or just send me the PDF, you know, that'll be part of your homework solution then. And some people do everything in here. It's all a matter of preference. If you want to, you know, a typical student though will handwrite, they'll scan that part, and I'll get that electronically with their handwritten solution, and then they'll interleave pages from the Markdown editor in here. And I can help you with templates and things, like for me, -- puts in a bar in Markdown, and then I've got my Markdown file set up that -- means page break. So I break a page automatically there when I go to PDF. And then that way I can separate problems out when I write stuff up that way. You get the idea?
Yeah.
Supposedly this guy's going to make us start paying for it someday, but so far it's free. So I like it a lot. I'm not a fan of it. I used it as a presentation tool actually at the SciPy conference. When Scikit DSP came out, I did a half-day workshop on it, and I used this as my presentation tool just because I could edit it on the fly if you get into a bind, you can always go back to see the source code, hyperlink. I mean, I actually use it for all kinds of things. I start writing stuff, and I might export out as a Word document or something, and that's pretty handy. If you need to export out into other languages, you might find you need to install Pandoc, which is an open source tool for file conversions. Pandoc is also free, and that Typora works in combination with Pandoc. I have a link over to Miniconda. Another tool I thought about was Thonny, which is a beginner's tool for Python. I think it was made popular by the authors. I think they're in somewhere, not in Europe, they're in Africa, I think, for teaching. But what I found was kind of nice about this tool is that you can manage packages because it's got a visual package manager inside of it. And then you can launch a terminal from that, and you can manage packages and update packages, remove packages, rather than doing that at the command line. So it's just an option. You guys don't care about it, but I think in my other class, people are gonna maybe be interested in it. And if you want to go with Julia, on Linux, I've got it directly installed. On Windows, I like using this Chocolatey. I never knew this existed, but it's a theme of chocolate, if you like eating chocolate as candy. But it's a manager, and what I like about this for like Julia is that there's new versions coming out all the time. This provides a nice means of managing this open source package, so you can automatically update it without having to figure out how to remove the old version, which can be painful sometimes. Right now my Linux version is kind of stuck on another computer because I have to read some notes on how to do it more efficiently. And on my Macintosh, I use Homebrew for a lot of tools. And Homebrew is the same way. It's just very easy to update stuff and keep your packages in order. So, what time have we got here? Probably getting close to our break time. We're actually past break time, but I think what else do I want to do before we come back over this. Wait a minute, yeah. I'll go back over here. Let me just go through this, and then I think we'll be, we're a little bit further along, but homework is always due at the start of class, unless you have an extenuating circumstance. If you're traveling on business, then you let me know beforehand. Just let me know. I mean, don't not show up. Like the 3 people, those of you that aren't here, I wish you would have let me know that you weren't going to be in class today and were thinking I was going to do streaming or something, because it's just the right thing to do. I grade things on a straight scale, but I'll do curving below thresholds if needed. Since I'm not using Canvas, I don't have the automatic grading thing, but I'll keep you updated with having histograms. I always use histograms. I'll even go down to show you a histogram of the homework grades, of a particular homework assignment. So I just keep you updated that way, and I can share information on Slack or whatever we decide to use. And then I've already said we're going to come up with a password for solutions, and when I'm put this thing on pause, we'll do that. So we're going to take our break here really soon. Come back and talk about software tools, but what I want to do now is take a short 10-minute break, let's say. No, I'm not going to give you half an hour. And then what I want to do before we start up again, I want to have an icebreaker. And the icebreaker idea, this might not you might not be familiar with icebreaker in your country, but I'm gonna explain what icebreaker is. It's where a bunch of people are coming together, nobody knows anybody. So breaking the ice is the idea that we're gonna start talking, we're gonna get to know each other. So the icebreaker is just telling me a little bit about, each of you telling me a little bit about yourselves, and I'll do the same. And then we got some commonalities. We know something about each other, and it breaks the ice. I mean, I grew up in Wisconsin, so cold weather was where ice makes sense to me. Maybe in your country, ice doesn't make sense. I don't know, but you have snow, right?
Yeah.
And so I'm going to go back over to here and pause the recording. So hopefully this recording is running. I thought I'd just show you, because I didn't have a link for it in the webpage, if you just type into Google, like I showed here, Scikit DSP.com, you will get either to the GitHub site or more likely you'll get to the Read the Docs. So the site is it's my GitHub site. So this is kind of like the home base that it was developed in. And Trant is second generation from India. He works at a company here in town. He's one of my master's students. So I developed this when I was at the SciPy conference, and we had just decided to make a project out of it. So I created that logo when I was at the code sprints that occur when you go to a conference like that. But if you go back over to here, I'm just showing you this part. If you...
I think that that's a low pass filter.
Yeah, it is. No, that's not it. That's the PDF part of the documentation. No, that's the Read the Docs page. I'm getting to all the wrong links. The ones that I normally hit are, I guess the first thing. This is the Read the Docs, so this pretty much goes through with examples. There's Jupyter Notebooks in here. There's just a lot of stuff in here. He's going crazy with it. You want to be like this to your advisor. Just want to make nice stuff, and you might want to refer to it, but the doc strings in the package itself is what creates the Read the Docs documentation. So it's always there in Jupyter in particular. You can find it. But if you want to see some other examples, they are in here. And when I originally wrote this, this module down here, SIGSYS, was written to go with the Dummies book, and it was called SSD, Signals and Systems for Dummies. And when I went and presented a paper on it at the SciPy,
State drive.
well, it is solid state drive, but I called it SSD because that was the abbreviation for the
Right.
book. But I changed its name to SIGSYS and then started developing the other packages that you see on here that kind of support things that I do. And real-time DSP, I definitely use things like this coefficient to header file, so you can write C header files. I use that in my sabbatical because I was frequently writing header files in my C++ code
Or
for
just
things.
Python to generate C for you.
A little bit of C, yeah. I mean, I'm big on that, and I maybe didn't use those functions exactly, but I modified them to put test vectors and correlation vectors in and other things that I've been doing in the C world. So there's a synergy there. In modern DSP this semester, I'm going to propose maybe writing some C++, but I'm willing to bet nobody wants to do it. It sounds scary to a lot of people to write C++, but right now it's very easy to do on a PC. I mean, I'll just show you this. even though this is a Windows machine, I have Windows Subsystem for Linux on here, so I've got all my tools in here, and I successfully run GCC in Windows Subsystem for Linux all the time, and that's how I did a lot of my prototyping. I just used Visual Studio Code and use GCC and go off onto the Linux side of things. And this is just the launching of the Julia terminal. If you're interested in wanting to do it that way on a Windows machine, you've got something called the Windows Terminal that you can download from the Windows store. I don't know who's using what type of computer, but I use all three types. You've got an IBM, so you're running Windows 10.
Yeah, I use the Ubuntu for Linux and stuff.
You use which?
Ubuntu,
Ubuntu?
yeah.
Okay, so you're using WSL. You're using Windows Subsystem for
Yeah,
Linux?
I use Windows and I use the virtual machine.
Okay. You have a virtual machine or just the WSL?
WSL, yeah. I want to connect to the server in the EC, and so I use the Ubuntu, yeah, this one.
Okay. So you don't have a true virtual machine like with,
Yeah.
you do have a true, like, open, what's that called again? Okay, that works too. WSL to me is easier because it's more integrated with the operating system. As a open box maybe is what you're using. I don't know. But I use just the,
Yes.
I just use Windows Subsystem for Linux. If you use OpenBox, I guess you could run GNU Radio or something like that. Is that what you're doing with it? Are you running GNU Radio?
No, I just run Ubuntu to use the server and to run my code, my PyCharm.
Okay, is this Dr. Semiari's server?
Yeah.
Okay. Yeah, you can do that too, VPN, the VPN and SSH or something like that.
Yeah, I use the VPN.
Okay, and then you SSH to another machine?
Yes, yeah.
Okay, got it. Yeah, that's pretty nice because you can go over to here. I get that to go away. If I happen to be running, this is Visual Studio Code, I would use remote connection, so I would set up a remote connection to do a SSH session or something like that. So you can do things like that with VS Code. And then I have the debugger on here for C++ is what I ran, but Python tools, Julia tools, whatever you want to do. It's all there. Okay, so we were talking about the software tools, so we've talked about that probably too much, but I said that you would probably want to use SciPy Stats. I'm kind of previewing for the first homework assignment at least. And occasionally I've used SymPy in Python to do symbolic stuff, so you can do symbolic, calculus type stuff. It's kind of nice. And if you're using Pluto, and the only reason why I'm really thinking about Julia and Pluto is it runs much faster. That's the attraction to Julia as a language. It's a just-in-time compiler. It runs almost at the speed of C. So I've been doing some simulation work. I've written 2 modules for Julia, one called DSP Tools and the other one called COM Tools. I wrote this almost a year ago, and I was wanting to explore Julia to see how could it help me and how could it speed things up. So it can speed things up. I've seen speed ups over a factor of 10, like in a phase lock loop simulation. It just ran really, really fast. And for our purposes, it might be interesting. For this class, though, Python speeds have been fast enough for the simulations because I don't give you anything that takes a day to run, let's say. It might take 15 minutes to run a Viterbi algorithm simulation of a comm link to get a good error probability estimate or something like that. But comm systems engineers are always exploring that. Every engineer explores making simulations run faster, I think. That's just the nature of it. The whole thing I was doing with Xilinx has been app acceleration by running code in the fabric using parallelization of the high-level synthesis tools. So the thing about Julia that made it a really easy on-ramp for me is that Julia plays well with almost every other language because it's relatively new. It was developed at MIT, and Python has been out there. NumPy came out in about 2001, so it's been out for 20 years now. So the ecosystem for Python and scientific Python is fabulous. I mean, MATLAB came out, in about 1986, and I started using it. I love MATLAB, but it's so expensive, it's so awkward, and it's kind of behind the times in the way the language works. I don't need to justify that anymore to any student, but I like the languages that support namespaces and things like that. I think are just essential. I don't know what you guys think about the namespace idea, how tuned in to it you are, but it's just the way I think a language should be, having the ability to control your workspace, things like that. I like object-oriented concepts. I think they work well for common DSP type simulation. It's useful to have that capability. And Python is certainly easy to do object-oriented programming in. Julia, however, does not support it. It supports something called multiple dispatch, which is kind of funky or hard to learn how to use, but I've been able to use it. I'm not going to explain the details of multiple dispatch, but the creators of it are really into programming idioms from MIT, that they've done things in Julia that they have a reason for everything. I mean, they're very steeped in why they're doing it. Python is a lot more laid back, I think. We can or can't, and we get away with it. So Julia is, in my estimation, is a harder language to program in because it's fussier about things. But the cool thing about Julia is that there's a package called PyCall, and then there's a package called Conda. So you can build a small Conda Python environment right inside Julia, and then you can use things from Python right inside Julia. So it'll have the speed advantages for some of the computations, but you might use my scikit-dsp comm package to get some primitives created, like test vectors and things, but then the actual algorithm will run in Julia. So that's why I started exploring it. And it was because of this coupling. I'm not going to throw away scikit-dsp comm. I said maybe I'd write my own package for Julia, but I'm not really there yet. So I started writing just a couple of modules just to kind of see where it might go. I'm not thoroughly convinced. I'm old, but I explore new things. You guys are young, you have to explore new things. If you don't look beyond, what's going to happen? What do you think? What happens if you don't look beyond as a young engineer? What do you think?
It'll run past you and you'll get stuck.
What's that?
Technology will run past you and you'll get stuck.
Yeah, exactly. Don't take that seriously. It's absolutely true. I mean, I can step into an environment. I have people that want to hire me if I leave here, and I'm still viable in the community. If I would have not keep pushing on stuff, I think they would not even want to talk to me. They'd say, "You're dead. You can't do anything." I can't do everything though. So 5G, I'm not focused on that because I'm on these other things. I mean, that's the other thing that you have to come to reality. And Dr. Zener taught me that. I didn't practice it very well though. He'd always say to me, "You can't do everything. Quit trying to do everything. You got to just, do certain things." So just words of wisdom, and I'm sharing that because if this is my last year, I won't have the same forum to do that in ever again. So I'll just briefly jump over there with the time, a little bit of time here. So here's my web browser. I've got this notebook, which is on the website for first homework assignment called Probability and Random Variable Demo. I need to push up this newest version of it, but here I'm running my Pluto notebook. Pluto notebook. So I have a PhD student that's been looking at for his topic. I'll get it out of Slack here, that Jerry's been working on. His topic is this: practical partially decoupled Volterra equalizers for nonlinear TWTA, traveling wave tube amplifier, distortion in wideband satellite communications. That's a title, pretty long title, but that's what he's been working on. So TWTs are used in high power amplifiers in SATCOM systems. You're doing 5G, so you probably don't care about TWTs. I do a lot of things in SATCOM, so they're still used. HPAs, as they're known, high power amplifiers, and equalizing them was a big deal at one time in the creation. These are my markups to them, but so what a Volterra equalizer does is it doesn't just simply do the linear equalizer that we're going to be studying in this class. It works with nonlinearities. And when you run an amplifier at close to saturation, it produces nonlinearities, and that's what this little example is all about in here. Sela is the author of a paper on an instantaneous nonlinearity for high power amplifier. So I wrote the Sela model in a few lines of code in this notebook cell in the Pluto notebook. And it originally was written, a long time ago, was written in MATLAB code, and then I rewrote it in Python. But so it's sitting right in here. It has, what it does is it takes a complex signal and it transforms the phase with a characteristic called the AM to PM transfer function, and then it takes the amplitude of the input signal and transforms it to the output with an AM to AM, amplitude to amplitude characteristic. So this is modeling a high power amplifiers having these two characteristic curves. Is that, either of you ever heard of that before? AM to AM and AM to PM. It's a form of distortion that comm systems have to deal with.
That's a quadrature receiver.
This is complex signal, so yeah, it's in phase and quadrature. So this model assumes what we call complex baseband. We'll be doing complex baseband for everything in this class because that's the way a carrier-based comm system gets dealt with. So I'm sure you deal with that in your work.
Yep.
So, and all our modulations are written that way. So, but at any rate, this is a model that works at complex baseband for carrier modulated signals. So what I did in the beginning of this notebook, though, I'm just going to show this to you probably once. I've imported.
Because I'm wondering, does it have an ADC that produces, or a DAC, or an ADC that produces the two phases, or does it do digital down conversion into complex?
The TWT is just something that operates at a microwave carrier frequency. It's designed to amplify to a high power level on a satellite so it can broadcast down to Earth or Earth up to a geostationary satellite. So it's just a carrier-based signal. It's just a power amplifier at 12 gigahertz or whatever, 30 gigahertz. You could visualize it for 5G, but 5G would be 30 gigahertz or whatever using a solid state amplifier, solid state devices. But all amplification devices have these characteristics. They will have a point where they begin to saturate,
Right.
and the high power amplifier idea is, what do we learn in electronics? You have to put DC power into an amplifier to allow it to amplify a signal of interest. And when you're efficient, you're interested in efficiency, like in SATCOM or a portable electronic device, what are you concerned about? One of the concerns is how many watts of power from the battery,
Or your bias current.
to get to produce so many watts of RF power. So running an amplifier at close to saturation is very commonplace, so you can get lots of efficiency out of your amplifier, and that pushes you close to the distortion characteristics of the amplifier.
And so then you'd correct that in the digital domain.
Pardon me?
So then you'd correct that in the digital domain.
You'd crack it?
Correct it.
Oh, correct it, yeah. So nowadays, what people do in the high-power amplifiers is they pre-distort, so they'll pre-distort the waveform with maybe an FPGA or something else that they have running in the high-power amplifier, but existing legacy satellite systems don't have any such thing on board the satellite, so how can you correct it? You correct it on the ground side, just like you said. You correct the distortion with this Volterra equalizer is one approach, or other types of equalizers. We'll look at adaptive equalizers.
So the transmitter would send out a distorted, like essentially the inverse
Yeah.
of the distortion curve.
Yep. And by doing it at the transmitter, you're far better off, but people didn't know about that and didn't put that on board. Now we have pre-distortion things in handsets and other things. I mean, I'm not really keeping up with all that stuff, but the advantage of doing it pre-distorting is there's no noise involved. The problem when we receive the signal, it's already got noise and interference propagation phenomena with it, so we're trying to fix it, but it's not a clean noise-free signal, so we might enhance the noise. We're going to learn about that too, noise enhancement that an equalizer will give you. So this is an older topic, but it was something that over 10 years ago when I was doing a sabbatical, I bumped into this. I was on an equalizer project, high-speed equalizer. I was studying it, and then an implementer was putting it into FPGA for a customer. That customer was NASA for one of their systems. So just to show you how Pluto works here up above here, I'm using PyCall, and I'm just directly importing. This is Filter Design Helper. I'm importing Digital Com from Scikit DSP Com. I'm importing all these things so I have access to them in Pluto. If I wanted to do it all in Python, I could be just as well off, but the point is to see if I get some speed up advantages of working in this domain. So I have all that stuff imported. Then I have some native functions in Julia code. So now I'm just going to create some random bits, and this is accessing random bits that I have in my own my Julia module called ComTools. I put it on a carrier, and I can either put it on a carrier or not. So I have two different types of filters. Right now it's set up to do, it looks like a low-pass filter. If I uncomment it, I can do a bandpass filter. So right now it's just doing complex baseband low pass. And then I send that in this block through a linear filter that's going to apply a band limiting filter, which is generally present in a receiver. And then I have my SALA height HPA model. And notice I have variables plugged into these. I get to define the filter coefficients on the fly if I want to, and I can define the amount of back off. Back off is a term that satellite operators use to say we're going to back off from the full saturation by so many dB. When I worked for one company one summer, everything I was modeling on this NASA project was how many dB of back off would the link be operating at, and how are we going to develop the equalizer so that it can work, and that was part of the requirements. Engineers do not we always work with requirements, right? It has to do thus and such, so I was playing around in my modeling a lot with the back off. So this is a power spectrum of the filtered, this is just rectangular pulse shaping. We'll play around with pulse shaping, most certainly in match filters and all that good stuff. So that's the filtered signal in red,
Is
the,
that like when you look at an eye diagram and it gives you a correction filter?
yeah, there's an eye diagram right down here.
So
Exactly. You know, you're good. This is all the stuff we're going to do. So because of the reactive nature of the Pluto notebook, I can control the amount of back off with a slider. So here, because the video processor is running in here, it's not really as responsive as I'd like it to be. So if my back off drops down to almost 0 dB, I'm starting to get the AM to PM conversion. This is a binary phase shift keyed signal, and this is the scatter plot coming out of the demodulator after it's locked onto the carrier. And I'm just seeing the added phase rotation because the AM to PM conversion of the amplifier is rotating the phase. Make sense? We have a device, and it's just, as the drive level goes up into the device, it starts doing AM to PM. And if I wanted to just drop down the signal to noise ratio, I see that I start to get a cluster. And this is just a knob in here, so I can pretend that I've got a tracking loop in here. So I'm just, going to put the phase, and we'll be looking at this distortion later, or this effect. I want to have my tracking loop get the real and imaginary. Well, the orientation of this constellation will be such that the two clusters are on the real axes. And I just threshold at 0, and I can detect my zeros and ones, which are minus ones and plus ones. But if the back off level gets worse, then the constellation gets worse. If I increase the noise a little bit. That's 10 dB of back off. I think the project that I worked on, the back off level was maybe, I don't have this slider set up. In the Pluto notebook, though, you can, let's see, you can hide cells, so the code in red is just the sliders, so they're very easy to put in, and so you can animate your code and play around with different things. And all the variables in here are changing with the sliders, and they're coupled with everything else in the notebook, like the plots or the eye pattern plot and so on and so forth. So that's what Pluto can do. I will try to see with my time how it factors in. It probably doesn't seem very exciting to you, and it looks like I got to learn a lot of stuff. So,
This looks pretty neat.
yeah, it's cool. I like it. And it was launched. Where was it launched? It was launched over here. So I brought up Julia by typing Julia, and then I imported the Pluto package, and then I typed Pluto run, and then it automatically brought up the web browser. Very similar to the way Jupyter works. So now we're out of time. So I think with the time that remains, we're not going to get started on the lecture, but the lecture out of the real chapter. But I just would like you to make sure before we leave here today that you know that this exists. There's a problem set here, and depending upon how things roll, I was optimistic when I wrote this, saying we could turn this in on the 10th. But no big, huge worries. We are sitting right here on the 23rd of August, Monday, the 6th is a holiday called Labor Day. We don't have class on that day. So I was thinking you might be able to get it done and turn it in on Friday just to show that you're making progress on it. If need be, it'll just be due on way down the calendar there. It certainly will never be due the following week because I always ensure that there's a class period where we can talk about it. And because we only meet once a week, I have to just always do it in 2-week increments so we can always have chance to talk. I can demo things in the Jupyter Notebook or just answer theory questions or whatever I need to do. Does that sound good?
I might have a different version of the textbook, I'm not sure. Could I bring it one day and just
Yeah.
check with you that these problems are the same?
Yeah,
Okay.
yeah, that's important, really important. It's really important because they did change. This is the last edition.
Or if not, could you scan the problems? Is that-
Yeah, I've been able to do that for people. I actually have a PDF version of it. William Tranter taught at Virginia Tech until he passed away.
I'll bring my book then, it
Yeah.
might not be the same.
Both of these guys are deceased. When I went to school at Missouri S&T, both of them were faculty members there. So is it creepy to know that I'm using a book of two people that are now deceased? They haven't been deceased for less than 2 years. I mean, only
They
months.
say you die twice, right? When you die and then when people forget you, so you're keeping them alive.
Okay. I guess that's a good way of thinking of it. I mean, a lot of really good books are all people that are deceased that I really like. I mean, because I'm older, obviously, but I think I probably don't have a whole lot more I can do. I'll have this overview next time because we're at 10:40, which is the end of class. I want to have an opportunity, though, to have you say anything more to me, any questions or anything you want to fire at me before we wrap up for the day. Be obviously reading ahead, start to look at the problems. I'll get this notebook. Oops, I just closed it because I hit the wrong thing on the keyboard. I have to reopen that again. So. Harder for me to open it up, but it should be right there. If it relaunches itself. Yeah, it'll eventually relaunch itself. So this is the notebook, and there's examples and things that could be helpful in some of the homework problems. There's an introduction to symbolic Python and some other things in there, and I will re-push the newest version of that up there, because there's calculations like this where you're doing some probability calculations, and I'm thinking, and study all the problems. Some of these problems are interesting in that if you use your calculator or you just use Python, there's occasions where you have to be careful how you calculate numbers. I mean, calculators maybe give you the wrong answer, but scientific tools like Python will probably give you the right answer because they have PDFs and things defined, so you get regular numbers. I mean, you get correct answers. Have you ever been there where you had this quandary? I calculated it this way, I get this answer. I calculate it using this other tool, and I get a totally different answer. That's kind of a calculus problem where you have limits and you have problems like that. Like, where does this come from in our uses? It comes from factorial usually, where you have a factorial somewhere which creates a huge number, and then it can't be handled properly unless you take a limiting form. So Python, I think I've got a picture of that in here. Since it just reset, it's probably not in here. There's a cool example in here though, where binomial distribution can be approximated with a Gaussian distribution. And then there's the Poisson approximation too. So we'll be covering that kind of stuff. This is all out of chapter 6. I know you have a background in probability and random variables, but I'm just wanting to make sure we can take everybody through a quick review so we're not foggy about everything, because if you don't use anything, you don't lose it, you just have to recall it and get back up to speed on it. And I want to have a good foundation for everything. Any other questions? Fatima, you didn't have anything more to say?
No, just about the textbook, the PDF of the book.
Okay, do you have a copy of the book?
No, if it's possible,
I can't give you a PDF copy because it's not legally shareable by me, but maybe Dr. Semiari will loan you a copy of his book or something. It's in the library, I think, too. Yeah, I'd like you to have the book to read. My notes are pretty comprehensive. They're written from the book, but think about that, how you can do that. I guess I'm done for the day.
Okay.
Are we good? You're probably not going to see anybody else from the class, but maybe, Joseph, if you see Ryan say what happened, I'd like to have a debrief from him, and nobody has written to me. He's a good guy. He's a good guy, and I don't know what happened, but.
I can see if I can ping him.
Okay. I'm going to stop my recording right now.